So here we are, Chapter 3, Sections 1-4. You're going to remind you several times here in the process to pause the video, look for things that you need to be writing down to yourself. There'll be times when I'm going to have you do some things online, so obviously do that there. You're obviously welcome to listen through the whole video first and then go back and redo it again, however you best process. But use pause and rewind effectively as we cover a lot of new content in these first 4 sections of Chapter 3. These are the basic ideas that we're going to be covering, which might be familiar to you anyways. You'll have some background in some of these areas. Don't just bypass it thinking that you don't need to know. How I explain it might be slightly different than you've heard it in the past. But then this is also a matter of getting familiar with or recognizing again certain aspects of what we're doing here in intermediate algebra as we cover everything from the Cartesian coordinate system, ordered pairs and quadrants, etc., down to verifying and determining perpendicular and parallel lines. So first thing you're going to want to do is grab your computer that you have and go to Desmos.com. Desmos.com will work best if you're using a computer or possibly a tablet. It works really well with tablets. On your phones, it's very small, and unless you're really comfortable navigating it around, it can be a bit of a challenge to get everything done. It can be done, it's just harder to do. Let me just say it that way. All right, so once you get Desmos.com opened up, it's going to give you a screen that looks something like this. So here we have our coordinate system, right? We have my x-axis, although not labeled here. We should always be in the habit of labeling my axes. This is my x-axis. Down here we have the y-axis. And as we're going along, remembering that this up here is quadrant 1, right? Because my coordinate axes make this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we talk about an ordered pair. You know, we're talking about if I take this point right here, that point right there would have coordinate -6 and -2. It's in the x direction first, and then the y direction. So x is left and right horizontal. Y direction is up and down in my vertical. Again, quadrants 1, 2, 3, and 4. If you're wondering why it's called Cartesian, it's actually because of René Descartes, a French mathematician, philosopher, and theologian, is the one who came up with it. So René Descartes, Cartesian, that's where it comes from. If you're familiar with wells too, Cartesian wells are a type of well, but regardless. So that's our quick reminder of this is our graphing system, x and y coordinates. That's the x coordinate, that's the y coordinate. And then over here in Desmos, this is where you'll type in equations and things like that. So for example, here, if you look at this point, 2, 3. So to do a point, you do a parenthesis set and then 2, 3 end parenthesis. And then down here, it'll ask if you want to label it. For what you're going to do for the assignment as part of watching this video, my answer is yes, you're going to label it. And specifically, though, you're not going to have 2, 3. What I want you to instead have is your birth date. So it'll be month, comma, day. All right, so for me, I was born in the 12th month, comma, 8th day. So I'd go over and I can't get to it because of this graph, because it only goes over to 10. So if I need to zoom out, if you're using a tablet, you can obviously use your fingers and zoom out like you would on any kind of an image, or you're going to zoom out using this negative sign over here to zoom out so that that point can get plotted. And then the label isn't going to be A. I would like you to label it as your initials. So mine is Brian Steffen, so it would be B and S for my initials. So when you're doing this, it's going to be your birth month and then your birth day. So December 8, and then those are my initials as the label. So that's one of the ways I'm going to verify that you're doing your own graphs as we're going along. And then I'd like you to graph this line, this line, this line. So to do -2/3, if you just start typing it in as -2, the divided by symbol, which is a \3, it will convert it automatically into a fraction, just like this. All right, to do x squared, we would type in x and then the caret key, and the caret key on a lot of keyboards would be Shift-6, and then the number 2, and it will automatically make it into an exponent. All right, so that's how you're going to do exponents. And then if you graph all 4 of those things on this same axis, then what I want you to do is actually I want you to save this and download it. So to do that, if you go to the upper right-hand corner, there will be this little symbol right here for sharing. So to share your graph, you're going to export it as an image. And when you export it as an image, this pop-up window will show up. And that's where you're going to download it as a PNG file. PNG is just like a JPEG. It's a slightly different version, but it'll download it as a PNG file. Pay attention to where it downloads it to on your computer or your tablet or your smartphone. So that way when you go to find it for the assignment, you can find this graph, which will have all your graphs in it, whichever ones you have and whatever point you have that's in there. I just had some random here so that you could see what it looks like. And then that will get uploaded as part of the assignment that you're going to be turning in for watching this video. So then we're going to jump into these different forms. So we have three basic forms when we talk about equations. Standard form is going to be ax plus by equals c. And that's where a, b, and c are really any numbers. So if I have an equation like 3x plus y equals 4, in that case, the a was -3, the b was +1, and the c was 4. The a is the number in front of the x, the b is the number in front of the y, the c is the number in front of the 4, or there's the constant all by itself. But to be in standard form, it's going to have the x and the y both on the same side of the equation, and it would be on the left side. That's how we write it. The whole number that's not associated with a variable, so it's not a number with a variable. A coefficient, I should say. So b is a coefficient, a is a coefficient, so c is all by itself. So this is standard form. Slope-intercept form is one of those ones that it seems like people are most comfortable with. So slope-intercept form is y equals mx plus b. Now that you're more sophisticated and you're in college, sometimes we'll see it as ax plus b, and sometimes we'll even see it as bx plus a. And the only thing that really matters when you're remembering this is it's y equals, and the coefficient in front of the y is a 1. So it cannot be 2y. It has to be y. So if it's 2y, I'd have to divide everything by 2 to get rid of that 2 in front. The number in front of the x, the coefficient in front of the x, this is the slope. So no matter how it's written, these numbers are always the slope. And that means this constant number without a variable is the y-intercept. All right, and then the third form is what's called point-slope form. Point-slope form is y minus y1 equals m times x minus x1. And here, the m is the slope again, just like it is over here. The y1 and the x1. So here it would be like if I knew that I have an equation that has a slope of 2, and it goes through the point 1, 2, I can take these values and plug them directly into this equation. This m, this 2 goes in for there. The y1 is the point that it goes through. The x1 is the point that it goes through. So then this would be y minus 2 equals 2 times x minus 1. And then I would be done at that point because that is in point-slope form. I could obviously take this, distribute the 2. I'll go ahead and do that for us quick, just so I can put it into slope-intercept form. So y minus 2 equals 2x minus 2. Make sure when you're distributing that you distribute that to both the terms inside the parentheses. And then to get it in slope-intercept form, I need to have a y all by itself. So I'm going to add 2 to both sides of my equation. Over here, I'll have then just y. And notice I wrote it here, even though it's under the x. These cannot combine. They're not both x's. So this 2 will have to combine with that 2. So plus 2 minus 2. I end up with 2x plus 0. And I normally don't write 0, but there it is. So what that means is my equation has a slope of 2 and the y-intercept. It intersects the y-axis at the point 0. So it actually intersects at the origin of my graph. So finding slope and finding intercepts. Finding slope, if I have equation in point slope, or excuse me, in slope-intercept form, that's the easiest way. But other times I'll have 2, 1, and I have a point -2. Actually, let's go, -2, 7. And there, we're talking about slope being, and there's a lot of ways we've talked about it in the past. Rise over run. So if you're looking at a graph, you can do that. Delta y over delta x. That's going to be our more sophisticated way of doing it when we get to physics and other things like that. y2 minus y1. And notice what I'm saying, y2 and y1 over x2 minus x1. That 2 and the 1 are subnotation, not exponents. Be very careful not to make them exponents. So in this case, I'm going to take my y2, and I'll call this 0.2. I'll call that one 0.1 only because it's easiest to remember, 1 and then 2, because we write left to right, we count left to right. So if this is 2, the 0.2, this is 0.1, this is my y2, and that's my y1, or my x1. Sorry, 0.2, y2, and that's my x2. Getting too fast on myself. So to do this, I would say this equals, my slope equals y2, which is 7, minus y1, that's the y component of the first point, so that's 1, divided by x2, it's the x component of my second point, this is my second point, that's the x component, so it'll be negative 2 minus, and then the x1 is that number there, and that's 2. And if it helps, I like to write subtraction as plus a negative. So I have 7 plus negative 1, which is 6. I have negative 2 plus another negative 2, that's negative 4. So this reduces to negative 3/2. When we're finding intercepts, what we're talking about there is looking at an equation such as 3x minus 2y equals 6. To find the intercepts, we do it two ways. The first thing we'll do is we're going to say, well, if x equals 0, then, so we're going to take in this equation, and where the x is, we're going to go 3 times 0 minus 2y equals 6. So this is 0 minus 2y equals 6. And since we normally don't write it as 0, we'll just leave it at that. And then we say, okay, solving for y, divide by negative 2. So the negative 2 divided by negative 2 is 1. I'm left with y equals negative 3 because 6 divided by negative 2 is 3. So if x is 2, then y is negative 3, which means I have this coordinate 0, comma, negative 3. That's a 0 because on a graph, and I'll make a tiny one right here, 0, negative 3, 1, 2, 3, right there, 0, comma, negative 3, it crosses the axis right there. And then to find the other 0, I say, well, if y equals 0, then dot, dot, dot. So I do the same thing. I take the equation. 3x minus 2 times 0 equals 6. So I then have 3x, and then this becomes 0. 2 times 0 is 2. Negative 2 times 0 is still 0. So this is 0. So I have 3x equals 6. Divide by 3. Divide by 3. X equals 2. So when y is 0, x is 2, which means that point is 2 comma 0. Again, because the x was 2, the y was 0. So at 2 comma 0, back up here on my graph, I'm over 1, 2, comma 0. I'm right here, 2 comma 0. And then that's my line if I'm going to graph my line through the two intercepts that go on there. Functions. Functions are an idea within mathematics, and we start talking about when we write it as f of x equals. So if I have an equation, say for example, y equals negative 3/2 x plus 2, that equation as a function is going to be written as f of x equals negative 3/2 x plus 2. It's same as saying y equals, but instead of y equals, now we're going to use this function notation. So if I need to find when x is, let's say 4, that would be, I would write it as f of 4, which means since I replaced this x with a 4, I'm going to replace this x with a 4. So then I'll have negative 3/2 times 4 plus 2, which is equal to, so f of 4 is equal to, so 4 is the same as 4 over 1. I'm multiplying fractions, negative 12 over 2 plus 2. I'm not going to do too much simplifying in every step, otherwise I'm going to lose track. Negative 12 over 2 is negative 6. Now I can just add those, and that's -4, which means graphically, when x is 4, the y coordinate is -4. And that's function notation. But more specifically, a function means that for every x, or for any x in the equation, there is only one y. Or in other words, no matter what I put in here for an input, this equation is going to give me only one output. What you'll sometimes see is this as a notation in our books too. It'll say like this point, and I have all these points over here that all have different values. These points all have different values. And this one maps only to that one. This one maps only to this one. This maps only to that one. This one maps only to this one. This one maps only to that one. All right, if this point, sorry, not that point, if this point not only mapped to this point, but also mapped to this point, so that one value here in my x, and now we're going to start being more sophisticated. My x is my domain. My range are my y values. But if I have this one x value that maps to this y value and that y value, then it's not a function. So what does that look like graphically? Graphically, it looks like this. If I make a graph, and if I have an equation that's like this, this is a function, and the easiest way I can tell is if I pick any value along the x-axis and I go up or down, how many times does it cross the equation or the line? So at this x value goes up, it touches only one place. We do what's called a vertical line test, which means if I take a vertical line and I make it go through anywhere on this graph, how many times does it cross the graph? If it's only once, then it is a function. If I have a graph, another graph here, x, y, and if I have a graph here that looks like a sideways parabola, and if I do a vertical line, it touches the graph here and here, which means that this x value, whatever that is, x is, there is a y value up here and a y value down here, so y1 and y2, they're two different values. So since that graph has x1 comma y1, and it has an x1 comma y2, there's two different values for the same x. This is considered not a function. Vertical and horizontal lines. A vertical line is like this. Horizontal line is like this. If we talk about it with respect to graphing, so let's say it's on an XY axis. Let me throw an X and Y axis in here. Here's my X and Y axis. X, Y. These points over here could be something like 4, 2, and 8, 2. If I were to do the slope function, y2 minus y1 over x2 minus x1, that's my slope. So here I'd have slope equals y2, 2, minus y1, which is 2, over x2, 8, minus x1, 4, of 0 over 4, okay? Hold on to that for a second. If I have these points over here, let's say this point is -4, 2, and this point here is -4, 6. If I do the slope on that one, y2, which is going to be 6 minus 2, for 6 minus 2, divided by -4 minus -4, that will equal 4 over positive 4, 6 minus 2, over 0. So I've got these two values, 4 divided by 0 and 0 divided by 4. And aside from just grabbing a calculator and figuring it out, it'd be ideal if you already knew this, but 0 divided by 4 is always 0. 4 divided by 0 is always undefined. It does not exist. You can't do it. We do it like this as an empty set because if you have a 4, and the question is how many zeros go into 4? All the zeros in the entire universe that exist would all go into 4, and I'd be left over with an infinite number because 0 doesn't take up any space. So a horizontal line has a slope of 0. A vertical line we say has no slope. The equation of this line on the right is going to be y equals 2. How do I know that? Well, look at the 2 points. The y-coordinate here is 2, the y-coordinate here is 2. The y-coordinate anywhere along that line for every point is 2. Since the y-coordinate is always 2, the equation is y equals 2. Here, every coordinate has the same x value, negative 4 comma 6, negative 4 comma 2, negative 4 comma 0, etc., etc., etc. This equation is x equals negative 4. All right, the other way to tell it, this is in slope-intercept form. Y equals mx plus b. B, my slope we said was 0, so y equals 0 plus the y-intercept. The y-intercept, where is it going to cross? It's going to cross over here at that point. So that'd be at 2, so plus 2, or y equals 2. This one over here is not in slope-intercept form because there is no y. Well, if there's no slope, then there's no slope, which means it's undefined slope. So a vertical line has no slope. A horizontal has 0 slope. Perpendicular and parallel lines. People often remember parallel means 2 lines do not intersect. So they don't intersect. You can think of things like train tracks, they don't intersect. Mathematically, when we say 2 lines are parallel, that means that they go, let's see if I can draw a couple parallel lines. Go like this, and like this, sort of, not super great. But if I did them correctly, parallel lines have same, notice the all caps, same slope. So if I have 2 equations of 2 lines, and I can find them, put them in slope-intercept form, if the m is the same, I have parallel lines. A perpendicular line, perpendicular means they run and intersect at a 90-degree angle. That's what perpendicular means. Perpendicular slopes, so if I have 2 lines, y equals mx plus b, and this is let's, instead of saying y, let's change that to function notation. I have f of x. If I have another function, g of x equals, and this would be m1 because it's the first line, and b1, so m2 x plus b2. If I have 2 functions, if they are perpendicular, m1 times m2 is equal to -1. So again, if you have them in slope-intercept form and I look at the 2 slopes and multiply them, they equal -1, then I know that the 2 lines are perpendicular. The other phrases that we've used in the past that you might be familiar with are negative reciprocals. Fancy math language that means you take, if one of them is positive, the other one has to be negative. And if you look at the picture here, you can see these lines are going up, positive, which means that to be perpendicular, it has to be going down, negative. So perpendicular lines always have opposite signs. One is positive, the other one's negative. That's the negative part. The reciprocal means they are inverses, not but inverses, but like inverted. So the reciprocal of 2 is 1/2. The reciprocal of 3/2 is 2/3. The reciprocal of 1/4 is 4. Those are all reciprocals. To be negative reciprocals, one of them has to be negative. Doesn't matter which one is negative. But if I take any of those pairs, here, here, and here, and multiply them, times, 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 this would equal -1. equals -1 equals -1 equals -1. And that's how the relationship between parallel and perpendicular. Linear or not, slope and intercepts, function or not, and graph it. So here we have an equation. And the question is it linear or not? To tell if an equation is linear, I look at the powers of the x and the powers of the y. If the power of the x and the power of the y are both 1, which these are, we don't typically write x to the first and y to the first, but they are, then this is linear. So I would say linear because powers on x and y are both 1. Slope and intercepts. Intercepts again, I'm going to start with that one. When x is 0, I'm going to take my equation, so I'm going to have, instead of the x, I'm going to have 6 times 0 minus 4 times y equals 10, or 0 minus 4y equals 10, divide by -4, y equals 10 over -4, which is -5/2. When y is 0, so this is my y, what's my x? So this would be 6x minus 4 times 0, because I'm replacing the y with 0, equals 10. 6x equals 10, because 4 times 0 is just 0. Divide by 6, x equals 10 over 6, which is 3/2. So my two zeros on this left side is 0, comma, -5/2. And my other 0 is when x is 3/2, y is 0. Those are my 2 points. If I need to find the slope, I can put it into slope-intercept form. So for that, I'm just going to move all this stuff here a little bit. Change my colors. 6x minus 4y equals 10. I want to have y all by itself, so I'm going to subtract 6x from both sides. 6x minus 6x is 0. I'm left with -4y. Don't forget that negative. It's very important. It's attached to the 4. On the right-hand side, I will have -6x plus 10. They cannot combine, remember. They do not have the same, they're not same terms. And then I will divide everything by -4. I'll have y equals, see, negative divided by negative is positive, so it'll be 3/2 x plus 5/2. And it makes sense that this is 5/2. Oh, I'm divided by -4. -4, that should be a negative right there. There we go. That makes more sense. So that's negative, and that changes this sign down here to negative. That makes more sense. That should have been yellow, because that's the y-intercept, and that's also a 0 when we're looking at a graph. My y-intercept is also a 0. So my slope would be 3/2. What is the slope of a line perpendicular to that line? A line perpendicular to that line, the slope would be the negative reciprocal. So I took this number, which was positive, made it negative, and then flipped it 2/3. Linear or not, well, right away I can see that my exponent on the x is a 3, which is not a 1. So I'd say this one is not linear, which means it's going to be some kind of a curve, which also means there's no slope. I'm not going to be worried about slope at all because it's not linear. To find zeros, I'm going to say, well, when x is 0, what does y equal? Well, y equals 0 to the 3rd minus 4 times 0. Well, 0 minus 0 is 0. So my intercept is 0, 0. Well, what about when y equals 0? So I'll have 0 equals x cubed minus 4x. So here's a matter of remembering back to algebra, your first algebra class you had, or the last algebra class you had. When I'm doing this and I have multiple x's, the first thing I need to do is factor. So I'm going to factor this. factor, which means really I'm looking at these two and saying, do they have anything in common? Well, they both have an x. So I'm factoring, which is also reverse distributive property. They both have an x. So I'm going to factor an x out of it. When I factor 1x out of x cubed, I'm left with x squared. When I factor the x out of the negative 4x, I get negative 4. And again, factoring is reverse distributive, so if I were to go back and do distributive property, x times x squared is x cubed, x times negative 4x is negative 4x. So again, it's reverse distributive property. This equals 0. So now I'm saying, okay, pretend I have two things. 0, if a times b is equal to 0, then either a equals 0 or b equals 0, because two numbers that multiply to 0, one of them has to be 0. What is my a in this case? My a is x, so I have x equals 0. Well, that's one of them. And what's the other one? It will be x squared minus 4 equals 0. Two ways to solve that problem. Either I go x squared minus 4 equals 0. I'm going to add 4 to both sides. X squared equals 4. And then I remember that the inverse of squaring is square rooting. And I say x equals plus or minus 2, because the square root of 4 is 2. Have to do the plus or minus because there's two different answers there. The other way to do this would be to remember, again, from your algebra class, and if you had me in the past, you know that this is a very, very important one. This is the difference of squares. It factors into x plus 2 times x minus 2, and that equals 0. And then it gets back up to this same idea. If two things multiply to 0, then either this is 0 or this is 0. In other words, x plus 2 equals 0 or x minus 2 equals 0. Subtract 2 from both sides, x is negative 2. The next one, add 2 to both sides, x equals 2, which is what we had over here, plus or minus 2. So I end up with 3 different places that the y coordinate is 0. So at negative 2, 0. At 0, 0. That's when we did up here. When x is 0, y was 0. When x is negative 2, y is 0. And then lastly, when x is positive 2, y is also 0. And what that means is if you go put this in Desmos, you will see that it is a curved line that crosses the x-axis 3 times, once here, and once here. Find the equation parallel to the following. Immediately get in the habit of doing this. Parallel means same slope. Parallel means same slope, which means my new equation will have the exact same slope as this equation. Well, but what I don't know is I do not know what the slope is of this equation. So I'm going to put it into slope-intercept form. I'm going to subtract a half x from both sides. I'll have negative y equals negative 1/2 x plus 4. I need to get rid of the negative, so I'm going to switch the sign on everything. So this is negative, it's now positive. This was negative, it's now positive. This was positive, it's now negative. My slope of this equation and of my new equation will be (1/2). It goes through the point negative 3, 5. So I'm going to use my equation y equals mx plus b. The y value is 5. My slope is 1/2. The x value is negative 3, and then plus b. 5 equals negative 3/2 plus b. I will add 3/2 to both sides, and I'll find that my b is equal to 13/2. So my equation is y equals 1/2 x plus 13 halves. Find the equation for the line perpendicular to the following. Well, it's the same line, so I'm going to just rewrite it from the previous side. Y equals 1/2 x minus 4. What is the slope going to be of my perpendicular line? Perpendicular means negative, reciprocal, which means it will be negative, because the slope over here is positive. So my new slope will be negative, and reciprocal is you flip the 1/2, so it's going to be 2/1, which is -2. This is my slope of this new line that goes through this point. Same process. Y equals mx plus b. My y coordinate is 5. My slope is -2. My x coordinate is -3 plus b. 5 equals +6 plus b, because negative times negative is a positive. I'm going to subtract 6 from both sides. B equals -1. So my equation will be y equals -2x minus 1. Again, the -2 because that's the negative reciprocal of 1/2. The b because I used the point it went through, the slope that I had, to find the b value. So then here's your assignment. So we already did this one. You're going to include the graph that you created and downloaded based on the work we did on the 5th slide of this video. Then what I want you to do is I want you to use your birth day and birth month again as the slope, day over month. And you're going to find an equation that goes through this point. For example, my birthday is December 8th. This means it is the 12th month and the 8th day. So the slope of my line would be day over month, 8/12. I reduce that to 2/3. So that'll be the slope of the line I want you to create that goes through this point. Based on how we did the last 2 slides, it's just following that same process. So in the text field, start by writing your birthday, and then the slope you're using, and then find the equation of the line. You can type all of your answers into the text field as well. It's not as simple, but explain what you're doing in every step. You know, when you add 6 to both sides or something like that, you're like, well, because I do the same thing to both sides, I add 6. So if you would prefer, you can write out your solution on a piece of paper and then upload a very clear photo of just your work. I don't want a big picture of your desk or your background. It needs to be a very clear picture as well, so make sure you're well focused and well lit to get that all to show up. And then you'll upload that in addition to the slide that you did from Desmos, from this one here. So you're going to be uploading this image and then doing this work in the text field, or you're going to be uploading this image and the image of the work that you did. Now, if you do it on a piece of paper, I would also like you to write explanations for what you're doing in every step, so that way I know what you know. So it's explaining it as you go, just like I did with this video. And this is all due by 10 a.m., by the end of class time on Tuesday. If you're watching this video after Tuesday at 10 a.m., then you missed it. You can still do the work. Good advice from any professor, and for any professors, if you miss the work, do it anyways. Send it as an attachment in an email, but don't always expect that it's going to be worth any points. But if you do it and show that you've done it, that'll always go well for you for maybe future problems that you might have, and demonstrating that you are committed to this class or any other class that you might be in. And then you're outside of classwork. So this is classwork. You just watch the video, you're going to do this. This would be no different than the hour and a half we would spend together in class. Last thing, and then the last thing is, this is what you're spending the other 3 hours on before we meet again on Thursday, or that the next class would be on Thursday, although I'm also out of town on Thursday, so it would be another video. So that's what I want you to do, is work on these. These are on the Check Your Understanding page in Canvas, so you do not need to be taking a screenshot of this. It's all on Canvas. Go on there. They're almost all odds, so that way the solutions are in the back of the book, or the answers are, and you can figure that out. That's why it's called Check Your Understanding. If you don't have Any questions on any of the work, then great. If you don't get right answers, that's when you consult with other people that are in the class to get answers. If multiple of you are working and still can't get there, that's when you come to me and we work on these together. If you're new to the class, welcome. This is not how we typically operate, but I'll see you again on next week, Tuesday, when I am back. But until then, this again is due at 10 a.m. on Tuesday. The next video will have something due, but not by the end of the class period. See you soon.